Have you ever wondered what it would be like to see spacetime? Spacetime, a concept that has fascinated humanity since the brilliant scientist Albert Einstein first proposed that time and space are not separate, but intricately woven into one unified structure. But what would happen if we could actually see spacetime? What would it look like? Imagine a reality where everything is interconnected, with no past, no present, and no future. Could this become a reality? Today, let's explore this intriguing possibility, backed by scientific evidence, and delve into the ongoing debates by top researchers about whether seeing spacetime is even possible. From a scientific perspective, spacetime is often explained through Einstein's theory of general relativity, which suggests that massive objects like planets or stars cause spacetime to curve around them, resulting in what we call gravity. To visualize this more clearly, imagine spacetime as a gigantic rubber sheet. If you place a heavy ball in the middle of the sheet, it will create a deep depression. Smaller objects placed near this depression will naturally move along curved paths, as if they were orbiting the mass. But can we actually see this curvature with the naked eye? Some scientists argue that spacetime is something that we can only observe through its effects on other objects. One of the most fascinating examples of seeing spacetime is the phenomenon of gravitational lensing. When light from a distant star passes through spacetime distorted by a massive object like a galaxy or a galaxy cluster, we see the light bent in unusual ways. As a result, we may observe distorted or multiple images of the star. Gravitational lensing provides a way for us to indirectly visualize, yet not all scientists agree with the idea that we can see spacetime. Some theoretical physicists argue that spacetime is not a physical entity that we can perceive directly. According to them, spacetime is more like a conceptual framework, a mathematical tool we use to understand how objects interact within the universe. However, some scientists, like Roger Penrose, have taken the concept further by suggesting that there might be a different way to perceive spacetime through quantum effects. Quantum theory suggests that fundamental particles can appear and disappear randomly, and Penrose has proposed that at these incredibly small scales, the structure of spacetime itself might become unstable and no longer be the continuous reality we think it is. Some theories of quantum gravity even suggest that spacetime might break down into tiny discrete units, similar to the pixels on a digital image. From this perspective, spacetime could be seen as quantum fluctuations, manifesting as tiny, discrete changes. In the end, spacetime remains one of the great mysteries of the universe. While we may never be able to directly see it, through the effects and phenomena it creates, we have been able to sense its existence in various ways. So, what do you think? Will there come a time when we can see spacetime directly? Or is it something that exists solely in our imagination? The question remains open, awaiting the next breakthroughs in science.